Hi, welcome to the next problem. So the problem says that there are three bodies or 3 points located at the vertices of an equilateral triangle have started moving towards the other. So if I were to say, then this body is moving towards the first body is moving towards the second body, and the third body is moving towards the first body. So after a very small time dt, the first body would have moved to here. Let's assume that. Then the second body would have moved to here. Then the third body would have moved to here. If I were to consider this as a very infinitesimal point in time, then at this point in time onwards, this particular body would be directed towards the body over here. So same way, this would be directed over here, and this body would be directed over here. Again, after a very small infinitesimal point in time, this body would be directed to this body over here. This body would be directed to this body over here, and this body would be directed to this body over here. So the path that's actually followed by a body would be more like this towards the center of the triangle. Similarly, the first body also would have a path towards the center of the triangle. The third body also would also have a path directed towards the sorry for the erroneous curve, towards the center of the triangle. So this way all the points meet at this particular location, let's say after a time t. We'll have to find out how soon after they start moving would they converge at this location. So for that we'll follow the below approach. Okay, let's make some space first before we go ahead. Okay, so what do we find here? We find that this particular body that's there, the first body, is moving in this, has a velocity vector in this direction. Second body has a velocity vector in this direction. So sorry for that. So the angle between them is 60 degrees. The initial distance between them is the side of the equilateral triangle, which is A. So the final distance between them has become 0 because all of them have converged to the same location. So if I were to see like the distance between any two consecutive bodies has been consistently reducing. See here, if you find the distance here, it's lesser. If you find the distance from here to here, it's lesser than the earlier distance. So if I take it as the change in distance as minus dA in a very small infinitesimal point of time by dt, that would be equal to the relative velocity between these 2 points. Okay, so which would be equal to v minus v into cosine of the angle between them. So how do I get the relative velocity? From this position, if I see the velocity v minus the velocity v, so this is the velocity v, and I reverse the direction of the other vector, so the angle which was 60 now becomes 120 degrees. So that would be equal to v minus v into cosine of 120. That would be equal to v minus v. Cosine of 120 is equal to minus 1 by 2. That's equal to v plus v by 2. That would be equal to 3 by 2 v. So going to more space at the bottom, minus dA by dt is equal to 3 by 2 v. If I have to integrate this particular expression, so integral of minus dA by dt, so from when? From a to 0, that would be equal to 3 by 2 v. So subtracting, so clearing the integration, we get dA by dt 0 to a. I just inverted the limits and removed the negative sign. Is equal to 3 by 2 v. That would be equal to a by t. That implies a by t is equal to 3 by 2 v. So therefore t is equal to 2a by 3v. This is just one of the solutions which is possible. We can probably look out for a separate solution. Come on, let's try to explore the separate solution. Now let me just remove the working which I have done. I'll let the diagram remain for future reference, but sorry. Yes, that's gone, and this one. Right. So now coming back to our problem at hand, for the alternative solution, I'll just mention it as alternative. If I see that this is a vertex of an equilateral triangle, I have a body which is moving in this direction with v, and the angle between them is 60 degrees. There is another body which is directed in this direction, with a velocity v. The relative velocity of both the bodies is, I have a velocity, if I take this as my mass, if I take this vector as the initial vector, this particular vector will have a rectangular component in the direction of the original vector. So the component in the direction of the original vector would be v cos theta, which would be v into cosine of 60 degrees. That would be equal to v into 1 by 2 equal to v by 2. So the relative velocity of body point 1 with point 2 would be v plus v by 2, because they are in the opposite directions. That would be equal to 3v by 2. So initially the separation of 2 points is a. Finally the separation at 2 points is 0. So the total time taken would be equal to a by 3v by 2. That is equal to 2a by 3v. So I guess this solves the problem.